Hello all, I am Pooja Shanbag and I'll be taking you operating system subject. The course code is 15CS43T. So first we'll see the course contents. So you have 6 chapters and as you can see it is the hours allocated and the marks weightage for each chapter. And your reference textbook is Operating System Principles by Galvin, 8th edition. Apart from that, you can refer these as well. Okay. So first we'll start with the chapter 1, that is Introduction to Operating Systems. So in this introduction, we will be covering these many topics. Okay. So first we'll start with a basic introduction, the definition and all. Okay. So the first one, what is operating system? What do you mean by operating system, right? So the operating system, it acts as an interface or intermediary between the user of the computer and the computer hardware. So this operating system is a program. Okay, operating system is a program that controls the execution of application programs, and it acts as an interface between the user and the computer hardware. If you take the more common definition, is that it is the one program. Operating system is one program running all the times on the computer. Usually it is called as the kernel. Okay, with all else being the application programs. Your your operating system is a software. Okay, and it controls the execution of your programs, and it acts as an interface between the user and the computer hardware. Okay, now let us look into the history of operating system when it was evolved. So the first generation of the operating system evolved during 1945 to early 1950s. Okay, the electronic device used was the vacuum tubes. The second generation of operating system, it evolved during 1950s to 60s, and the electronic device used was transistors. The third generation was from 1965 to 1980, and the electronic device used was integrated circuits, ICs. And the last one, that is the fourth generation. So since 1980 till date we are using the same one. Okay, so electronic device used is large scale integration, that is the PC. Okay, next we'll see the different types of operating systems. So the different types are your batch operating system, time sharing operating system, distributed operating system, network operating system, and real time operating system. So there are 5 types of operating systems. The first one, batch operating system. So here the sequence of jobs in a program on a computer without the manual interventions. Next, time sharing operating system. This allows many users to share the computer resources. That is, maximum utilization of the resources can be done. Next is distributed operating system. This manages a group of different computers and makes appear to be a single computer. Fourth one is network operating system. What happens here is computers running in different operating system can participate in a common network. So it is used for security purpose. The last one is real-time operating system. This means applications to fix the deadlines. Okay, there are 5 different types of operating systems. Now, what are the examples of operating systems? We all know, right? Basic examples are Windows, Linux, Mac OS, Android, iOS, etc. Then what are the goals of operating system? So the operating system goals are to execute user programs and make solving user problems easier. Another goal is to make the computer system convenient to use. The third one is to use the computer hardware in an efficient manner. So these 3 are the goals of the operating system. Next, we'll see what operating systems do, or the computer system structure. Okay. Basically, the computer system can be divided into four components, that is your hardware, operating system, application programs, and the users. The hardware, it consists of memory, CPU, ALU, IO devices, etc. Then operating system. As we all know, the operating system, it controls and coordinates use of the hardware among various applications and users. The operating system coordinates the use of hardware, okay, among different various system programs and users. Okay, it simply provides an environment within which other programs can do useful work. The operating system is a set of special programs that run on a computer system that allows to work properly. Your operating system, it performs basic tasks such as recognizing input from the keyboard, keeping track of files and directories on the disk, sending output to the display screen, and controlling peripheral devices. The next one is application programs. So this define the ways in which the system resources are used to solve the computing problems of users. So this consists of compilers, loaders, editors, web browsers, etc. The last is users. So user, who are the users? The people, machines, and other computers. So next we will see the diagram for this. Okay, this is the diagram. As we had seen, we have the computer hardware, then comes your operating system, then your application programs, and then the user. Your operating system acts as an interface between the user and the computer hardware. Okay, to understand more fully the operating system's role, we explore operating system from two viewpoints. One is user viewpoint and the other one is system viewpoint. Okay, first we will study about user viewpoint about operating system. So the user's view of a computer, it varies according to the interface being used. Most computer users, what they do, they sit in front of the computer, which consists of a monitor, keyboard, mouse, and a system unit. So such system is designed for a single user. In some other cases, what happens? A user sits at a terminal connected to the mainframe or mini computers. Other users are accessing the same computer through these terminals. These users share resources and may exchange information. In still other cases, what will happen is users sit at a workstation connected to networks of other workstations and server. These users have dedicated resources at their disposal, but they also share resources such as networking and servers, file, compute, and printer servers. So, recently, many varieties of handheld computers have also come into the fashion. So, most of these devices are standalone units and are connected to networks either directly by wire or through wireless modems and networking. So this is the user's view of operating system. Next we will study what is the system's view of operating system. So from the system view, that is from the computer's point of view, the operating system is a program most intimately involved with the hardware. In this context, we can view the operating system as a resource allocator. A computer system has many resources that may be required to solve the problem, such as CPU time, file storage space, IO devices, memory space, etc. So, the operating system acts as the manager for these resources. Your operating system, it has to decide how to allocate them to specific programs and users so that it can operate the computer system efficiently and fairly. A control program, it manages the execution of user programs to prevent errors and improper use of the computer. It is especially concerned with the operation and control of IO devices. Next, we will study about computer system architecture. So today's modern computer system, it consists of one or more CPUs and a number of device controllers connected through a common bus that provides access to the shared memory. So each device controller is in charge of a specific type of device, for example, disk drivers, audio devices, video displays, etc. Now, the CPU and the device controllers can execute concurrently. So, they, the CPU and the device controllers, whenever they execute in concurrently, that means they are competing for the memory cycles. To ensure orderly access to the shared memory, a memory controller is provided whose function is to synchronize access to the memory. So, whenever you start the computer, whenever you power it on or it is rebooted, it needs to have the initial program to run. Now, this initial program, we call it as a bootstrap program. Now, this bootstrap program, it is stored in ROM or it is stored in electrically erasable PROM, that is EEPROM. Okay, so it is known by the general term that is firmware within the computer hardware. It initializes all aspects of the system from CPU registers to device controllers to memory contents. Now, this bootstrap program must know how to load the operating system and how to start executing that system. Now, to accomplish this goal, your bootstrap program must locate and load into memory the operating system kernel. So, once it is done, the operating system it starts and executes the first process, for example initialization process, or we call it as a init, and it waits for some event to occur. Now this occurrence of the event, it is usually signaled by the interrupt from either the hardware or the software. Based on the processors used, the computer systems can be divided into two types, that is single processor systems and multiprocessor systems. A single processor system contains only one processor. So, there is one main CPU which is capable of executing a general purpose instruction set, including instructions from user processes. Next, multiprocessor systems. So, here what will happen is it contains a multiprocessor system, it contains multiple processors and a method for communication between the processors. That means these systems have two or more processors in close communication, sharing the computer bus and sometimes the clock, memory, and peripheral devices. Now we will see the advantages of multiprocessor systems. The advantages of multiprocessor systems are increased throughput, economy of scale, increased reliability. So the first advantage is increased throughput. So if multiple processes are working, then the throughput of the system increases. That is, the number of processes getting executed per unit of time, it will increase. That means again, you expect more work to be done in less time. Okay. If suppose there are n processors, then the throughput increases by an amount just less than n. The second advantage is economy of scale. As because these multiprocessor systems they share peripherals, mass storage, power supplies, etc., they cost less than the equivalent multiple single processor systems. Getting it? So the third advantage is increased reliability. So if functions can be distributed properly among several processors, then the failure of one processor, it will not hurt the system. It will just slow down the systems. So this is another advantage of multiprocessor system. Now this multiprocessor system can be again divided into two types, that is asymmetric multiprocessing systems and symmetric multiprocessing system. So in asymmetric multiprocessing, what will happen is each processor is defined, or it is assigned a specific task. The task is predefined. Okay. So here in the asymmetric multiprocessing, you have master-slave relationship. A master processor, it controls the system. That means it controls other processors. So the other processor, what will they do? They either look for the master to give the instruction, that is they wait for the master to give the instruction, or they just do the predefined task. So in the asymmetric multiprocessing, you have a master-slave relationship. Next is symmetric multiprocessing. So here each processor performs all the tasks within the operating system. That means here each processors are, or they act as peers or colleagues. Okay, there is no master slave relationship exists between the processors. So this is the basic diagram of symmetric multiprocessing architecture. Okay, so you have, as in the diagram you can see, you have three processors. They have their own work. They just behave as a peers. There is no master slave relationship between them. Okay, so this is about multiprocessing systems. Next we will study about dual core design. So this is the basic architecture. So a recent trend in the CPU design is to include multiple computing cores on a single chip. So this diagram we have shown you a dual core design with two cores on the same chip. You can see over here, right? This is one chip. This is one core and this is another core. Both are embedded on a single chip. Okay. Now each of these cores have their separate registers as well as the cache. Getting it? Now, the other design might use a shared cache or a combination of local and shared caches. So we have another type of multiple CPU system, that is clustered systems. So like multiprocessor systems, these clustered systems gather together multiple CPUs to accomplish the work. Cluster systems differ from multiprocessor systems in that, in the cluster system, what they how it is composed is of two or more individual systems. As you can see here, this is one system, this is another system, and this is the another system. These three are different systems. Okay, and these systems are joined together to form the clustered system. So this clustering is usually used to provide high availability service. That is, service will continue even if one or more system in the cluster fails. So this is one cluster which has three computer systems. Even if one system fails, the other two will work. So high availability is generally obtained by adding a level of redundancy in the system. A layer of cluster software runs on the cluster nodes. Now each node can monitor one or more of the others over this LAN or over network. If the monitored machine fails, the monitoring machine can take the ownership of its storage and restart the application that were running on the failed machine. The users and the clients of the applications, they'll see only a brief interruption in the service. So this is about the clustered systems. That's it for today. We'll conclude our session. Thank you.